we're going to talk about applying everything that we've learned regarding arc length, circumference, circles, the whole bit, to some real world type situations. So working with that is always a little bit challenging, but it's something I think that you can probably handle. So here we go. The first two deal with the idea of population density, which is a topic in the book that isn't super important, but it's something it applies here. So let's take a look at this. It says about 430,000 people live in an area of a 5-mile radius of a town's hall. Find the population density in people per square mile. Well, first off, we have to find the area. How many square miles are in this circle? So, area of a circle problem, pretty straightforward. The radius is 5 miles. So the area is pi r squared, or 25 pi miles squared. Now, obviously for a problem like this, even though it's a nice, beautiful number in terms of pi, we do need to decimalize that. So 25 times 3.14 is 78.5 miles squared. And the population density is the number of people per mile. So just as a hint, if we've got people per square mile, excuse me. So we're going to put people on top of our ratio and miles squared in the bottom, because people per square mile, people over square miles. And we know we have 430,000 people for 78.5 square miles. So we simply take the 430,000 and divide that by the 78.5, and we get 5,477.7, or 5,478 people per mile squared, square mile. Okay, that's a density problem, number of people per square mile, and that's a unit cancellation thing like you do in science class, and that's kind of what we're doing here. So let's do another one. It says a region with a 3-mile radius has a density of about 6,195 people per square mile. Find the number of people who live in the region. It's a little bit different. It gives us the density this time. It wants to know how many people live there. But again, we have a radius of 3 miles. So my area of my circle is going to be 9 pi square miles, or 9 times 3.14. It helps if I push the right buttons on my calculator. 28.26. And every square mile has 6,195 people. So in this case, they give you the density, they want the total population. So we're just going to multiply this number by 6,195. And we have 175,071 people in that area. Now, you'll notice both times, if you're following along in your calculator, you aren't getting whole numbers here. We always round up to the next whole number because I can't have 0.7 of a person or something like that. Whenever we're dealing with people numbers, you always round up to the nearest whole number. We don't do decimal values. So that's population density. You'll see a couple problems like that. Another application, obviously, is finding circumference of things. And here's a tire. It's saying this tire has these dimensions. It's got a 15-inch rim, and the tire itself is 5.5 inches wide when properly inflated. How far does the tire travel when it makes 15 revolutions? So we first need to find the radius of the tire, or the diameter of the tire in this case, because it wants to know the distance around the outside of the tire. Remember, 1 revolution of the tire means that this point here goes all the way around the tire and comes back down as it rolls. Okay, that's 1 revolution of the tire. So we're looking for the circumference of the circle. Well, circumference is easier. Circumference equals pi times diameter. And diameter here, we just have to add up our distances. So if I have 5.5 inches and 5.5 inches, that's 11 inches. plus the 11 inches there, my diameter is 26 inches. So my circumference is 26 pi inches. But again, real world problem, so we're going to go decimal answer, 26 times 3.14, 81.64 square or inches. That's my circumference. Well, 15 revolutions, every revolution, it takes one time around that tire, 81.64 inches. We're doing that 15 times. So we're going to take that 81.64 times 15, and we get 1,224.6 inches. Is that my final answer? No, because it asks to the nearest foot. So how do we convert inches to feet? We have to divide by 12. So we take that number divided by 12, and it's 102.05 or 102 feet. Because it says to the nearest foot. So 15 revolutions of that tire takes me 102 feet. You may need to go and watch this again just to make sense of it. But again, to find the distance around the outside of the tire, we are taking circumference to do that. So interesting stuff. Here's an application about a strange track that has a different radius for each end. So basically what we have here is we have two half circles and two straightaways on our track. And what it's saying is, how far is it for one lap around this track? Well, I know I got 84.39 meters here and 84.39 meters here. I need to know what is the measure of this arc in length and what is the measure of this arc in length. They have different radii, so they're going to have different lengths. But the nice thing is each of these arcs is exactly a half circle, so I'm going to find the circumference and divide it by 2. So the circumference of this circle, of the green circle, is pi times the diameter. Now the radius is 36.8. Okay. I'm sorry. It's the same circle on each side. Now I'm reading the problem a little more carefully. Isn't that what I always tell you to do? Read the circle. The radii is different here because the runner on the blue is actually running farther because they're running around that larger outer radius. We just want to know the red track here. Okay? So the circumference is pi times diameter. The diameter is going to be 36.8 times 2, or 73.6. So 73.6 times 3.14 is 231.104. Okay, now, since they're on the red track, and I've actually read the problem correctly this time, since on the red track, that's the same here as it is here. So actually, I'm going to put these two half circles together and use the whole circumference. So they travel this entire 231. Half of that 231 happens here. Half of that 231 happens here, plus the straightaways, plus another 84.39. So take that plus 84.39 plus another 84.39, and they get 399.884 meters, or about 400 meters exactly. There's a 400 meter track for you. Okay? There's a beautiful 400 meter perfect track. And that's a pretty standard type of question. Now one for you. A car tire has a diameter of 28 inches. That's all the way around the tire, everything, the full diameter, wheel and everything, the whole diameter here is 28 inches. It says, how many revolutions does it make while traveling 500 feet? So you're going to have to find the circumference of the tire and then relate that to 500 feet to find how many times it goes around before it goes 500 feet. Now remember, this is in inches. You're going to have to, when you find the circumference, you're going to have to convert that to feet before you can answer this question. All right, good luck. This one's going to be a little tougher. Here's an interesting area one. It says a rectangular wall has an entrance cut into it. You want to paint the wall to the nearest square foot. What is the area of the region you need to paint? So what we have here, the blue wall, that's what we're going to paint. I'm going to find the area of the wall, which the dimensions here are 26 feet by 36 feet. So if I did the whole wall, okay, that's 26 by 36. That's 936 square feet. But I have to subtract from that the doorway. Now the doorway I'm going to split into two pieces. I've got a rectangular piece, which I know the width is 16 and the height is 16. So 16 by 16 is 256 square feet taken out. And then I've got the semicircle part up here, which is so the area of a semicircle is just area of a circle divided by 2. Area of the circle is pi r squared. If the diameter is 16, the radius equals 8. So the area of the whole circle is 8 squared times 3.14. So 64 times 3.14. And then divide that by 2, I get 100.48. So again, I found the area of the, as if the whole circle were there. I cut it in half because I'm only using half the circle, divided it by 2, and that's what I come up with. And so the area I have to paint is 936 minus 256 minus 100.48, or 579.52 square feet is what I'm painting. And that's a pretty significant difference. And this is a very real world type problem. If you're painting and you got to buy the right amount of paint, you need to know how many square feet you're painting, because paint is rated by the number of square feet it covers. By the way, real world tip, if it says it covers 400 square feet, it probably doesn't. It's probably only going to cover 300. Always buy a little more than you think you're going to need. Take it from a guy who worked mixing paint for many years. So strategy is huge here. You really need to work on your strategy of how you're going to set up the problem. Last couple problems. We're going to skip this one for now, but this is one for you. Find the area of circle H. Now I'm going to give you a little hint. This is not a real big strategy problem. This goes back to yesterday's work, finding the area of a sector. So I'm going to help you start setting this up. We're given the area of the sector. I'm going to call that S right here for you. S is 214.37. The angle is 85. The 360 goes down here. You need to find the area of the circle. Actually, we'll say area. AC would be circumference. And basically, I just set it up for you. I hope you can get that solved up. We'll see you in class.